Hello, today we'll be doing waves. Waves are pretty easy in physics, to be fair. You just basically use two equations and they are c equals f lambda and v equals f lambda. They're the same equation, just c and v are two different values. I'll tell you those in a second. And another one is frequency equals 1 over time period. Okay, now what these mean is c, which we call the speed of light, which is c equals 3 times by 10 to the power of 8 meters a second to the minus 1. So this is the speed of light in a vacuum. And the c for the value here, you'll only put if the wave is going at the speed of light in a vacuum. This f here just means frequency. F for frequency. I mean, it's quite easy, to be fair. Lambda is this weird thing that we use. We call this wavelength. It's this part of a wave. So if you have a graph like this, you have a sinusoidal wave going like this. The wavelength will be from this point here to this point here. So it will, if you said from a standing wave like this, you'd say that it's from a node or an antinode. It's a good question. Anyway, he says from this point here, and then there's another one. Yeah. Anyway, so it's this pattern anyway. You can see it goes all the way up above the graph and then under the graph. And that's pretty much it for these two equations. V here is just any speed. We call V a velocity, so any velocity or speed, they're the same thing. That a wave's going, so a wave doesn't have to be going at the speed of light in a vacuum. Only light would go that fast, I guess, or any electromagnetic wave in a vacuum. So this equation here is pretty much the same. You can get a frequency in hertz, and all that means is 1 over the time in seconds. So yeah, that's pretty much it. It's quite useful if you have a time of a wave, the amount of time of a wave, and you want to find out the frequency that it's going at. Okay, I have a question down here that we can use. What is the frequency of a wave that has a speed of 0.4 meters a second? So this time we use v, and a wavelength of 0.02 meters. So that means v equals 0.4 meters a second, and lambda that we had done earlier is 0.020 meters, like that. So just use the equation v equals f lambda. It's quite easy. You just rearrange this, so v over lambda equals frequency, and then getting my calculator, which is not in my hand, so I'll use my phone. You just do 0. Oh, this is really easy actually, I didn't realize. So you do 0.4 over 0.02, which, I mean, is just the same as 4 over 0.2. So it would be 2, 10, 20 hertz. That's the answer. We can do it on the calculator to double check, but I'm pretty sure I'm right. Have a look on here for a calculator. So we do 0.4 divided by 0.02, and that equals 20. So frequency, which is in hertz, as we also stated earlier, the answer is 20 hertz. The other equation, frequency equals 1 over time period. Let's say we had this frequency 20 hertz here, and we want to find out the time period. We would just say that 20 of the time period, we'll call this t, with a capital, sorry, equals 1. So this must mean that t equals 1 over 20, which you would know is 0.05 seconds. Alright, well, thanks for watching the video, and hopefully this helped with wave equations and such. Thanks, and bye.